Okay, this video we will discuss how to work with complex numbers. All right. Okay, let's go. Number one is asking you to evaluate quadratic formula. Okay, remember quadratic formula is negative b plus or minus square root of b squared minus 4ac. And that looks like 4ac whole thing over 2a. Okay, and you are given the values of a, b, and c, and you're just asked to plug those numbers in, all right, into the formula, and you will get a negative radicand in the square root. That's why we end up ending up with a complex number. All right, so let's begin. Here, so this, okay. All right, so negative b, so negative of negative 6 plus or minus square root of negative 6 squared minus 4ac whole thing over 2a. Okay, then let's see, that should be, let's clean up a little bit, 6 plus or minus square root of 36 minus 4 times 9 is 144 whole thing over 2 times 4. Okay, and that should look like 6 plus or minus square root of 36 minus 144 is negative 108 over 8. Okay, and of course that negative radicand will give me square root of 108i over 8. Okay, and 108 is 36 times 3, meaning that can be reduced as 6 times square root of 3i over 8. Okay, we're not finished here because 6, 6, and 8, they are all divisible by 2, so I can divide that by all three numbers by 2 and have our final answer of 3 plus or minus 3 square root of 3i over 4. But remember, it's asking you to write the answer in a plus bi form. Okay, what I have there is not a plus bi form, so I have to separate the real part, which is 3 over 4 plus or minus 3 square root of 3 over 4i. That is now a plus bi form. All right. Okay, then let's continue with the next problem, number 2a. Okay, number 2a, you have two complex numbers multiplying, and I know this looks like binomial. We cannot call it binomial because these are not polynomials, all right? But we do have 2 terms times the 2 terms. So this is really nothing more than doing usual FOIL, okay? So multiply 5, distribute negative 2i, and let's see what I get. 5 times 3 is 15, plus 5i, minus 6i, minus 2i squared, all right? That will be 15 minus I, 5i minus 6i is negative 1i. And remember, I squared is negative 1, so negative 2i squared is plus 2. All right, so the answer comes out to 17 minus I. That's now a plus bi form. Okay. All right, to b. Here I'm going to use a binomial square formula. Remember, binomial square, a plus b quantity squared. So this is going to be 4 squared minus 2 times 4 times 3i plus 3i squared. All right, that should give me 16 minus 24i plus 3i squared is 9i squared. Remember, I squared is negative 1, so that's going to be negative 9. Okay, and 16 minus 9 is 7 minus 24i, and that's it. Okay, if this was a little too quick here, 9i squared is equal to negative 9. All right. Okay, number 3, we're doing the division here. But division is almost like doing so-called what we did before with radicals, rationalizing denominator. Here, we will need to multiply top and bottom by the complex conjugate of the denominator. 3 plus I, its complex conjugate is 3 minus I. Okay, so here we do need to do this so-called FOIL. So let's see what we have, what we get. So in the numerator, 1 times 3 is 3 minus I minus 9I plus 3I squared. Okay. And the denominator, I have a plus b times a minus b form, so that should be 3 squared minus I squared. All right, let's see what I get from that. All right, let me clean this up a little bit. I have a 3 minus 10i plus 3i squared is negative 3. Okay. All right, so 3's cancel out. Okay. And 3 squared, the denominator is 9. And minus I squared is plus 1. All right. Okay, the answer turns out to be kind of interesting. So that is equal to negative 10i over 10. Well, that's same as negative 10 over 10, which is negative 1. So answer is just negative I. All right. Okay, part D is similar to part B, just that it hasn't been written in I form. So let me do this one. So negative square root of negative 2 is negative 2i. And 12 square root of 12 is going to be 2 square root of 3 minus square root of negative 8 is square root of 8i, which is 2 square root of 2i. All right. Okay, so that's what we have. And what we need to do here, let me rewrite this. Square root of 2i at the top, 2 square root of 3 minus 2 square root of minus 2 square root of 2i. And I do need to multiply in order for me to divide this by the conjugate. Okay. And on the numerator, I'm just going to distribute square root of 2i inside. Well, this is again a plus b times a minus b. All right, what do I have enough space now? So what I have is, let me go ahead and distribute square root of 2i. So that is going to be, let me write everything out. It looks a little bit messy here. Square root of 2i times 2 square root of 3 plus square root of 2i times 2 square root of 2i. Okay, the denominator is going to be 2 square root of 3 quantity squared minus 2 square root of 2, and that will be I, that's squared. Okay, maybe a little bit more room here. Okay, so what I have at the top is going to be 2 square root of 6i, and the second one is going to be plus 2 times 2i squared, and that's because 2 is here. Square root of 2 times square root of 2 will give me another 2, and I times I is I squared. Okay, and the denominator I have 4 times 3 minus 4 times 2i squared. Okay, remember that I squared is going to make this subtraction to positive. Okay, all right, so what I have is, I'm going to write this first because that's going to be the real part. That's 4, but it's I squared, so that's negative 4 plus 2 square root of 6i. And in the denominator, I have 12 plus 8, which is 20. Okay. All right. So what I have, I'm trying to find a space here. Negative 4 plus 2 square root of 6i over 20. All right, that is equal to, now I need to split this a plus bi. Negative 4 over 20 plus 2 square root of 6 over 20i. Okay, reducing fraction. Negative 4 over 20 is negative 1/5. It looks a little ugly. Negative 1/5. And 2 over 20, of course, is going to be square root of 6 over 10i. All right, a little bit ugly, but that should be our final answer right here. All right, that's it for this video.